In this video, we're going to look at the last form of quadratic equation, and this is called standard form, but it's not necessarily the most useful, but it really depends on what you're looking for, because a lot of parabolas, this might actually be the most useful format. So the general version of standard form looks like this, where ax squared plus bx plus c is just kind of written out. You'll notice that the squared always comes first, and then the x by itself without an exponent, and then the c is always just like a number. And if you want an example, we've got one up top here. And this is actually what it looks like. That is the same equation or same graph. Now, the only number you can take directly from the equation itself that is useful is this one right at the end, and that's the 6. And you can plot that point immediately. That is the y-intercept. But obviously, one point is not nearly enough to make a whole parabola, so you might have to do a little extra work with these ones. The nice thing about this, even though I picked one that had a nice vertex, the roots are terrible. They're like decimals. They're really hard. They have like decimals that just go on and on and on. And I was able to find them because from standard form, we're going to learn a fancy trick next week that will teach you how to find the roots even when they are really weird decimals. Now, a in this case is still the stretch factor that still works in exactly the same way as in the other forms. And just recall that c is your y-intercept, because if I made x 0, all of that stuff in the front would turn to 0, and all you'd be left with would be c. Now, to graph, we have a few extra steps. We can't just like start with the vertex and bam, know exactly what it's going to look like. Instead, we have to do a few extra steps, and those are to find the line of symmetry. If you are going to memorize anything in this unit, this would be a good one. If I'm working from standard form, to find the line of symmetry, I can calculate it by this formula, x, the x value of the line of symmetry, which remember, it's a vertical line, so I can write the entire equation of a vertical line as x equals a number. That equation can be calculated as negative b divided by 2 times a, or 2a. Then I'm going to take that x value and I'm going to plug it back into whatever equation I started with, and that's how I'm going to solve for the y value of the vertex. That way I can use the x from the line of symmetry, the y that I calculated when I plugged it back in, and then that is my vertex. I need 5 points to make a good parabola. All I'm going to do is use the same structures that we've already been practicing by looking at a, the stretch factor, and what that tells me. So for instance, up here in our example, a was -1, which tells me that this is a parabola that opens downwards. It also tells me that it is not a skinny one or a fat one. It's one that follows the usual over 1, down 1, over 2, down 4 pattern. So I used that to find my 5 main points and ended up with a beautiful looking parabola. Even though the roots are super weird, I could still use them. We'll learn how to calculate those next time. Let's do one practice together. All right, so we're going to graph this equation, which looks super weird, like 27, -16. Those are big numbers. Obviously, 27 is really high up on the graph. I'm not going to start with the y-intercept. That's not a very useful point to me. But I can calculate the line of symmetry. So, using my formula, negative b over 2a, I like to assign the negative to the top part. It just makes it a little bit easier. So because b, in this case, the second number, so this is a, this one's b, this one's c, it might be helpful to actually write that out as a list for yourself. It's a good strategy. When I plug it in, when I plug b in specifically, it used to be negative, so all I'm going to do is just change its sign. And on the bottom, don't forget to use some parentheses, otherwise you'd look like you had 22 down here. 16 divided by 4 is a positive 4, and I've found the x value of my vertex. Now I have to plug it back in, and you might ask, where do I plug it in? You plug it in where the x is, which in this equation happens twice. So you're plugging it in here, and you're plugging it in for x there. X is the same number for the vertex. Do a little math. Remember your PEMDAS. Exponents happen first in this one, and then multiplication. And then make sure you do your addition and subtraction left to right. Same with multiplication and division, those happen left to right as well. We get -5, which is the other half of our vertex, so 4, -5 gives us all that we need to start our graph. So if you plot that point, it should be right about there. And then we're going to look at A, our stretch factor, to figure out the shape. So A is +2, and because it's positive, that means it opens upward. So I'm going to be looking at going over and then up. And because it's a 2, I'm going to multiply those up times 2. So instead of going over 1, up 1, I'm going to go over 1 and then up 2, because 1 times 2 is 2. And then over 2 and up, not 4, which would be our typical. I'm going to go double that, so 4 and then 8. And you'll see that that's where I got my main points over here, over 1, up 2, over 2, up 5, 6, 7, 8, to get to those 5 points. And it should look symmetrical. If you end up with one side that's looking wonky, just recount. Make sure you're starting your count at the vertex every time. See you in class.